I'm Bernardine. Please call me Bernie, and I come from the Institute of Mathematical Sciences of the University of Malaya. And I have been teaching there for, well, a little over almost 23 years already. So I'd like to share this morning briefly on using Wolfram Alpha to teach or to help students learn at the Institute of Mathematical Sciences. Before I go to that, allow me to tell you a little story as to why Mathematica. Why am I interested in Mathematica as opposed to, say, other things? Okay, a little bit of my experience. I did my research work at the University of Malaya back in the 80s, and my research was in nuclear physics, theoretical nuclear physics, and it involved computation, but a large part of my work was on trying to find closed form or analytical expressions for certain quantities. So a lot of times when I tried to look for analytical expressions, I would be opening up handbooks of integrals. Those of us who are theorists know, and looking through to find where is that integral there from a few thousand integrals, and if we are lucky, we get the integration and we have the formula. Someone was, previous speaker, Dr. Gobi, was talking about incomplete gamma functions, for example. So I'd be happy if I found an incomplete gamma function. I'd say at least I got some formula, So a lot of my work was on that. So my orientation and my research interest is always for looking for analytical formulas. However, in those days, my research work involved computing using Fortran programming and using legacy programs which dated back to the 1960s, which were not structured, which had a lot of go-to statements. Younger people will not encounter go-to statements, but a lot of my master's and PhD work was looking at Fortran programs and trying to figure out, okay, if this condition is met, where do I go? What happens? And it was quite a challenge. And at the end of my studies, I heard of this program called Mathematica. And because it promised to do symbolic manipulations, I was instantly hooked. And I actually came across an article. In fact, I still have the copy of the journal called Computer in Physics. And it's a 1991 article. And it talked about the use of Mathematica in a classroom. Now, if you think about it, now it's 2016. We're talking 25 years ago. In Case Western Reserve University in the United States, they were using version 1 or perhaps version 2 of Mathematica to teach scientific programming, to teach physics. So I was interested when I read the article. I said, wow, wouldn't it be great if we could actually have something like that to use? And as I read the article, I discovered that the inventor of Mathematica was a certain Dr. Stephen Wolfram. And when I read and I saw that name, it rang some bells because I had come across that name before. And those of us here who are physicists will, I think, recognize the person on the left, and the person on the left is the late Professor Richard Feynman, Nobel Prize winner in physics, who was an icon at Caltech, where Stephen Wolfram did his PhD and graduated with a PhD at age 20. So he has a reputation. So when I saw that Mathematica was invented by Wolfram, this genius, I thought, wow, there must be something to it. And plus, he was a physicist, so he would understand the needs and requirements of a physicist. So I was instantly interested. I started working at the University of Malaya in 1993, and a large part of my teaching has had to do with scientific computing. Started out teaching Fortrans, structured Fortran. And then when we discovered that companies were not so interested in Fortran and more interested in C, we migrated to C, and subsequently, until today, we still teach C++. In the meantime, we also taught Excel and also up to this day, MATLAB as well. And you might be wondering how come we didn't teach Mathematica. And the reason is officially, up to very, very recently, University of Malaya had only one license of Mathematica. Individual researchers would have their own licenses, but these were not campus-wide licenses, and you couldn't use it to teach. So with one license, there wasn't much you could do, okay, at the University of Malaya as far as Mathematica was concerned. But as of this year, things have begun to change, and I would say a little more of why Wolfram Alpha and what I've tried to do with Wolfram Alpha since this year. On the research front, I have also used Fortran and MATLAB and also Mathematica. Thankfully, to research grants, we managed to buy some of these licenses of Mathematica, and I started using it. Was trained by Dr. Paul Abbott, one of the early pioneers of Mathematica. Now, I would like to say here that since I got the Mathematica in the year 1998 or 1999, I am now an expert user of Mathematica. Unfortunately, that is not so. As you can see, even this is not given as a Mathematica notebook. Okay, why? Well, as I was invited by Peter to speak, I have tried to reflect as to why I am not a power user of Mathematica, although I would like to be. And I think the reason for that is because of our training. I was trained using structures. You have repetition, you have a do loop, you have an if statement, and there's a certain way of coding. Whether you code in Fortran, C, MATLAB, it's always the same. The style is the same. But Mathematica is functional programming. You have a function wrapped around another function, wrapped around another function, It's very powerful. But for a person whose original language is not like that, it takes a bit of getting used to. And I'm slowly getting it, but it's taking a while. So why did I start eventually using Mathematica more rigorously? I found that in the past few years, Mathematica has become easier to learn. It used to be, in my opinion, a bit hard to learn. The terminology they say used to be steep learning curve. And I understood the meaning of steep learning curve. But it's become easier now, especially with the large number of training videos and helps there are, and a lot of improvement in the functionality. So what I've tried to do was to use Wolfram Alpha in the classroom where I teach at the University of Malaya. I teach two courses. One course is called Mathematical Methods 1, and the other one is called Scientific Computing. I have 19 students in the Mathematical Methods course and 17 in the Scientific Computing course. When the semester started in September, I asked them, how many of you have heard of Mathematica? Nobody raised up their hands. Okay, in that class. But when I asked them, have you heard of Wolfram Alpha, at least it was not zero. Okay, out of the 19 students in the Mathematical Methods course, 5 said they had heard of it. I didn't ask them specifically, are you using it regularly? But I just said, have you heard of it? They said yes. In the Scientific Computing course, we had 9 out of 17. So I think there is an issue at the university as to awareness. Okay, so now that I've established how many actually have heard of Wolfram Alpha, what I've tried to do was to apply it in the classroom. And one of the ways I've tried to do it in the classroom is, like, for example, in the Mathematical Methods course, basically it's learning how to solve ordinary differential equations. First order differential equations. How do you go about solving it? So as we learn the various techniques of how to solve first order differential equations, we use Wolfram Alpha to say, okay, let's write down how do you solve that equation, what's the answer you get, and check against whether what we have done in the class with the answer is comparable. So this was a way of getting students to become at least willing to try out Wolfram Alpha. So they'd see that on the screen, and they'd see the answer that they expect to get on the screen, and a lot of other things, and it was good. I found that students were interested in it. Now I noticed there was also an option there that says show the step by step. Okay, so either fortunately or unfortunately, if you want to get the step by step solution, you have to subscribe to the pro version of Wolfram Alpha. When I was thinking about it, initially I said that's too bad. The students can only see the answer but cannot see the steps as to how you got to that answer. But then when I thought about it a little further, I thought if the students could see step by step from day one, they would immediately put in the equation, show the step by step solution, look through it and say, yes, that's right. And at the end of it, they'd come to the illusion that they actually understood how to solve an ordinary differential equation because they didn't have to do it. So maybe I'm happy that they need the pro version to be able to see step by step. It's good enough. I think they can see the solution and other things that are there. Another way I've tried to get the students to be more and more adept at using Wolfram Alpha is in the tutorials that I gave to them. I would just have a little thing that said, look, you can key in this kind of thing in Wolfram Alpha, and you can check your results to see if the results are actually right. Okay, so that's something that I've tried to do as well. The second course that I teach is a course on scientific computing, which is a final year course, and basically, in addition to using Wolfram Alpha, what we've tried to do is to get them actually to look at Math World, for example, sites like Math World, to see Wolfram Math World, to see what are information about things like Legendre polynomials, Bessel functions, and so on. And I'm very happy that in the last 2 weeks, the University of Malaya has got a site license for staff and students. Now they have access to Mathematica Online as well as System Modeler, and I think Workbench too. Yes. So again, in an assignment that I would give to a course, I have at the bottom, you can check your results against Wolfram Alpha. Basically, it's to create the awareness, to create the confidence in the students that they can input something and get Wolfram Alpha to say. Unlike Mathematica, if in Mathematica you wanted it to get the right answer, you'd have to be very precise about your line. If you made a mistake, if you didn't have the square bracket or something, it wouldn't respond. But Wolfram Alpha, being a knowledge engine, is actually very forgiving of that sort of thing, and that's good for students wanting to, and also for the rest of us who want to know more about the results. I've also had one experience of using Wolfram language for research, and that's my latest PhD student. He was doing some work in solving Schrödinger equation and in his work, you can see it's a study of analytical solutions to the bound state problem in non-relativistic quantum mechanics. Never mind if you don't understand the title. The important words is finding analytical solutions. And he decided earlier on that he would use Mathematica for his research. And as he did so, as he tried using Mathematica, he actually found a number of results. One of the results was from a complicated integral, he could find a functional form, an approximate functional form that actually gave a result which was very significant to his work. So I was very happy that he was able to do that. When he ran into trouble, he consulted Mathematica Stack Exchange. and which is a community of mathematical users. I've never used this Stack Exchange before, but he used it. He posed his problems. He had people helping him to get answers. And I thought that community learning aspect is something very 21st century. We are not so used, especially those of us who are from the 20th century, doing collaborative study. And this is one example of it, which I think is very important. So finally, he's happy. He's right there, getting his degree 1 month ago, his PhD, and I'm glad too that he's passed out, and I don't have to worry about him anymore. Finally, to conclude, Wolfram Alpha is an exceedingly useful knowledge engine. Probably the only weakness that I can think of as far as my teaching is concerned, it's concentrated on solving differential equations. Whereas Wolfram Alpha is a knowledge engine, it can answer many questions in many disciplines. I'm not sure that my students have reached a point where they realize that, or only are looking at it to solve math problem. It's very accessible. It's not limited, as I mentioned, to the STEM discipline, and it deserves to be better known. And the semester is not yet over. At the end, I intend to give a little bit of a survey to ask them, not only do you know what Wolfram Alpha is, but how often do you use it? What do you use it for? So that at least I'd have some idea of what they are doing. And finally, the Wolfram language is very powerful in its numerical and symbolic programming capabilities. Its functional method allows it to be very compact and tackle very powerful kind of problems, and very broad too. And I think it's a great tool that I hope that the students and staff of University Malaya particularly will take great advantage of. I'd like to thank the organizers of this conference today, OAMMS Intipaka, Wolfram Technology, and also PTM, who are the hosts, for giving me the invitation to speak. Thank you very much.